This is the Omaha Beach Capstone Team Sprint 2 review. Team members include Ethan Stankiewicz, Bradley Harrison, James Gamara, Lorenzo Lachey, Paul Shurky-Chacon, Jeremy Beasley, and Levi Nappergrant. Our product vision is to create a fully functioning 3D augmented reality representation of the Omaha Beach landings, paired with a physical map that enhances understanding of the historical content through an intuitive, interactive, and immersive experience that reaches a broad audience.
Our Sprint 2 goal was to place one fully functional module onto the 3D map mesh that can be clicked on and explored by the user. For Sprint 2, our capacity was 141 hours. We multiplied 7 cadets times 6 lessons times 3.5 hours per lesson. However, we needed to adjust for Jeremy not being here for the second half of every lesson due to his schedule. The estimated hours for Sprint 2 were 135.5 hours, and the actual number of hours we spent on Sprint 2 was 145.75 hours. This is a review of our burn down chart. Currently we have 5 hours remaining. This is due to the fact that we didn't complete one of our tasks on our project backlog. That task was to design the module that you actually click on. Right now we just have a default ball in there, and we did not get to design the module itself. Just for a broad overview, here's a list of our high-level tasks. These tasks are broken down into smaller subtasks on our sprint backlog, but in order to accomplish the sprint goal, we were going to conduct planning, place a clickable module on the map, create the design user interface, publish the historical content, and then field the app to the App Store and conduct file size management, and lastly present. Based on feedback from our previous sprint, one of our tasks was to conduct file size management. First of all, we set a requirement of 149 megabytes for a maximum amount size for our app. The cellular limit is 150 megabytes, so we wanted to be under that so people can download the app over cellular data. For reference, our map is currently 35 megabytes, so that means we have 114 megabytes remaining. However, we are trying to increase the resolution of our map, so we anticipate the amount of storage our map consumes to go up, so that'll lower the remaining amount of storage we have for pictures, text, and other historical content. The graph that you can see is just a representation of common education apps compared to Facebook. It shows that our limit of 149 megabytes is reasonable and within the realms of other educational apps and well below commonly used apps such as Facebook. The next two graphs just help to show the likelihood of a user downloading an app of such size. As you can see, the average file size by category graph shows that games are usually the largest apps downloaded, and education apps are usually around 43 megabytes, so our app does surpass that, but we still think that it's well within reasonable bounds and that people will not be dissuaded from downloading the app because it is 149 megabytes.
I'm Cadet Harrison along with Cadet Gamara and Cadet Lachey. We were tasked with creating functionality so that our map displayed in the AR environment, and there was a 3D module that we could click on the map to display our user interface that would provide the historical detail for the app. Our team was able to successfully display the map as well as a 3D module that hovers above it. However, when the camera moves, the sphere stays in the same geographical location, but the map does not. The map just stays wherever the phone goes, and we're trying to fix this in future releases of the app. You can also not resize the map. No matter how you scale it, it stays the same large size and covers a significant portion of the screen, so we hope to also fix this in a future release. Our team was not able to get the UI to appear once the 3D module was clicked. Our current issues with doing so are that we could not figure out how to switch from the AR scene to a storyboard view. So that's to say we are not able to switch from the AR environment to a regular app view. We are currently working on the logic to do so. We believe we do have the logic in place to sense when the 3D module has been touched, but we are not able to switch between the AR scene and the storyboard view. Another one of our tasks for this sprint was to add our app to the App Store. We, however, did not complete this task. Our app was sent to Apple for review, but they just rejected it on the grounds that our functionality was too minimal and our metadata was inaccurate. This is because our descriptions that we made did not necessarily reflect the app as it stood in its current state, and were more descriptors of what we envisioned the finished product of the app to be. In future releases, we hope to resolve these problems and get our app to successfully upload to the App Store. A few of the problems that we faced during this stage were that I initially believed that this was going to be an easy process and that it wouldn't take that long, but later realized that there were several small subtasks to complete in order to get our app on the App Store. We also were trying to figure out how to manage certificates and provisioning profiles on Mac's user interface as well as Xcode's, which proved to be difficult at some points. And we also needed to gain the necessary privileges to access certain accounts, such as the App Store Connect account, which we eventually gained and were able to successfully send our app to be reviewed by Apple.
This is Cadet Nappergrant, one of the two members of the history department team. Myself, along with Cadet Jeremy Beasley, have been working on constructing some of the historical modules, of which we've completed a few. This is the first one that I completed. It's Defending Fortress Europe, and it talks about essentially the German fortifications along the Atlantic Wall. The big problem with this one, after discussing with Professor Waddell, was that it's a little too general and not specific enough to the sectors of Easy Red and Fox Green directly north of Colville-sur-Mer. But this will even need to be narrowed further depending on what sort of updates we get with regards to the map from the geography department, as I'll show here on the next document. This is the second piece of content that I did for this sprint. It's Operation Neptune, Omaha Beach, and the Colville Draw, as you can see. And what it basically discusses is a little bit into Operation Overlord and then a little bit into Operation Neptune, but specifically jumps right into the section about Omaha Beach and the responsibilities of the 1st and 29th Infantry Divisions, specifically with a focus on the 16th Infantry Regiment, who really had the responsibility of the eastern sector of Colville Draw, which is this draw right here that I'm highlighting on the map. The problem being at this moment is that the story that we'd like to tell and what we did our research on mainly highlights the journey of Lieutenant Spaulding of E Company 16th Infantry Regiment, who landed on the eastern section of Easy Red and essentially followed a path up the bluffs and around, flanking the strong points of Widerstand 62 and 61. That would be covered in these larger areas is what we'd like, but currently all we have is the sections in between here. As you can see, based on looking at the actual 3D model screenshot, there's the draw itself and the roads that were on the map ahead. For reference, there's Widerstand 62, which is right there. And missing from this model is essentially the path of Lieutenant Spaulding. And for future bits of the historical content, we might have to essentially write that from the perspective of soldiers that were over here, an area that we actually can work with. And this is just something that we're going to have to go take forward with us as we finish up our first final historical content draft to be reviewed by Professor Waddell at the end of the semester. We're currently working with the geography department to see if they missed any files and we can get this section of the beach, but if not, we are prepared to write it up in a way that meets the intent of the project.
Today I'm going to demonstrate plane and light detection. This right here will make a light node which will be used to update lighting conditions the camera detects to promote authenticity on when the map's actually implemented on the application. And this here ensures the camera detects horizontal surfaces such as floors and tables. Other functions used on this app right now currently add a white plane when a surface is detected and add chip scenes when a user taps their screen on a detected plane. This video will demonstrate the application's ability to change a scene's brightness depending on the lighting. While this video shows lighting in rather extreme conditions, whether very bright or very dark, if the lighting does decrease slightly or increase slightly, the scene should update to show that. This video shows plane detection, the app's ability to update planes as it continues to detect more horizontal surfaces, adding a scene to a plane, and confirming scenes are anchored to that plane where they will not move and you can maneuver around and the scene will stay in the same place. Okay.
This is Cadet Shoki Chacon, and for this sprint, I was tasked with designing the user interface for everything that happens after a module is clicked on the map view. This is the template that I was working with to start, and I discovered this application called Sketch, which has a lot of really good built-in tools for creating UI. The advantage of using Sketch is that I can set the opacity, the contrast, and a lot of other aspects about the different elements of the UI in this, so that when I export it to Xcode, that's that much more processing that Xcode doesn't need to do on these images, and that should speed up our app runtime. The current functionality of this app is the ability for text to scroll and movement in between different frames. Some of the improvements that need to be made are that on different size screens it looks janky, so getting scaling down for different devices, as well as integrating the different buttons functionalities. So we hope to include 3D models of different items that'll pop up here on the screen, as well as get this picture to expand. And the major goal for next sprint is to get integration with the map, so we can go back and forth between this view and the map.
Hello, this is Cadet James Gamara. For this sprint review, I was tasked with altering the ball position, or creating a node along with the map that was able to be clickable and usable. As you can see here, we use the function create ball along with the ball shape and ball node to basically adjust this using the radius and geometry. I was able to do this quite successfully. However, our ball was not clickable. Over here, you can see that we were able to alter the ball, and the fact of we can change the color, we can change the texture based off various texture files. So we were generously successful in this area, We were able to implement it, as you're going to see in a few seconds here. However, as we stated before, it's unclickable, but that we don't project that to be a future issue for much longer. As you can see here, this is the implemented, like with all the ball mutations that we made. The ball is fixed, but and it's a much larger, and we're able to change the color of it. The map, we were able to stabilize that as well. But besides that, we met our goal of adding the map and the ball, but we do not have functionality to click the module like we intended to.
This is a view of our updated project roadmap. As you can see, we updated the Sprint 3 goal to include finishing the first module since we weren't able to fully complete our Sprint 2 goal. We successfully created the pieces that we need in order to have a fully functioning module, but since we did not integrate those pieces together, we do not have a complete module and therefore did not complete our goal. Additionally, our app was sent back to us from the Apple Store, so we will need to resubmit to the Apple Store in Sprint 3. We also hope to add modules 2 through 4 into the Sprint 3. Once we can successfully build the first module, creating modules 2 through 4 will mostly be replicating the same process we used in Sprint 2, and it should go a lot quicker.